It's really, really fun to be back in Istanbul, even though it's virtual this time. I love being there. It's amazing. It's very nice to say Merhaba Istanbul, and yeah. Let's get started. Well, we'll get to chat about things afterwards in the chat and on Twitter and stuff like that. So. I usually like to start this talk by showing off a kind of the final product or the thing that I ended up putting together at the end. This also means that I'll have to do some magic with sound, because the microphone, I'm not sure if it's going to pick up it well, but we'll see. We'll try. So, hey Google. What's the bike availability next to my house right now? Let's see if it works.
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
All right. So I hope you've heard this kind of reply that explained me the patterns and availability and possible availability and like the trends, how things are going up and down, and there will be more bicycles available and less bicycles available and things like that. So now let's explain what it actually was. So let's kind of rewind back in a bit in history, in time, and time machines are a fantastic thing, aren't they? Let me explain you what we're actually talking about. So the bicycles I'm talking about, this kind of bicycles like that. They're all over the world. I mean, you can see them in many different cities. So this is two kind of random pictures. I change those pictures from time to time depending on like the places I travel and stuff. But well, since I haven't been traveling much for the last half a year, so it's kind of the same pictures. So this is the one that you see on the blue bicycles that you see on the right, a bit darker picture. That's Oslo. So this is the bicycles that I'm talking about. This is where I live. And the ones on the other side, the red ones, a bit lighter picture, that is a bicycles from I think it was, yeah, it was in Belgium. So when I was in Devox, Belgium, I had this. I was passing by this place where they had this bicycle. So this is the bicycles I'm talking about. And the thing with these bicycles is that you can rent them at some point in a city, and then you can bike wherever you want, and then you can park them. And that, in theory, it sounds really fantastic. And this is kind of, I asked the folks from Oslo bike sharing company to ask them for some pictures, and this is pictures that they sent me. Right, it's summer, it's green, it's nice, it's fantastic, and things like that. And yet another picture. So this is like, this is what you're looking forward in the spring, because, well, the thing is, this is how approximately a bit less than half a year of the weather of the city in Oslo looks like. The other half of the year, it might look a bit more like this. So hence the question that Sebi was asking you just before we started, if it's winter already in Oslo. Well, it's not. It's not like this yet, but it's getting a bit chilly. So I mean, it's not 20+ degrees anymore. So yeah. So the thing is that, the spring comes, and this is what you're looking forward to. Oh, finally I can get to rent some bicycles. And when you actually want to go to a place and you buy this membership thing and everything, all these kind of things, and then you need to go somewhere. So what you actually expect is to find this stop full of bicycles. This is a place right across the street from where I work. So I see this rack of bicycles almost every day, in and out, like at least twice a day. And this is how you expect it to be, right? This is what you think it's going to be looking whenever you need a bicycle. In reality, it looks a bit more like this. So it's exactly the same stop, just from a little bit different angle, but it's empty. There is nothing in there. And there is yet another picture from a bit more the same kind of angle. So, well, yeah, see, bicycles, you see no bicycles. So this is what actually usually happens. And that really sucks a little bit. So then you get a bit sad, and then you're like, I paid for this thing, and it's still, not available, and what do I do with this thing? So then you realize one thing. Well, I can do IT. I do work for an IT company. I do solve this all kind of problems all the time. What can I do about that? So let me kind of try to find a solution. And this is where we got into this data pipeline things that we'll get back to in a few seconds. So the kind of you start patching this master plan of trying to figure out how system works and to understand what you can do to get this bicycles whenever you need them, or to know where you can actually get one. So first thing you do is like, okay, well, we don't have any bicycles. That sucks. Well, life is unfair sometimes. What can we do about that? Well, I don't really sure what we can do about that, because I'm not working for that company that is distributing bicycles. I'm not having access to too much data about all that, so what can I do? Can I use an app? Well, because obviously they have an app where you can lock and unlock bicycles and see availability and everything. Not really, because the thing is that availability that is shown in this app is a real-time availability. So it's right now, right at that place. And if you're sitting at home and your bike stop is 2 minutes away, you know that by the time, if there is one bicycle left, you know that by the time you get there, it's probably gonna be gone. And that kind of sucks. So what you can do about that? Well, can we use a public API? Well, maybe we can do that. The problem is that the public API does not provide historical data. So it will provide you real-time data, and that's it. And it has like a very specific JSON format, and well, it's a kind of RESTful-ish service that provides you data, real-time data. Okay, but how can I would like to have historical data, because I want to know the trends. I want to know what's the probability of getting a bicycle in, say, on Saturday morning, or on Monday evening, or Monday morning when I'm actually going to work, or something like that, right? So how can we do that properly? Can we build like a proper, go all crazy, all enterprise, and build like a data warehouse and all this kind of things, and spend lots of money on servers, on software? And this is how it kind of would have been. Obviously, you wouldn't do it as a person, as a private person, but this is how it would have been for companies doing things and processing data some years ago. But at some point is that, well, you cannot write things your own, because it will be quite difficult to maintain later, and you cannot also you don't really want to have all this crazy enterprise software running on your some kind of machine at home, because then you need like server racks at home and things like that. That kind of sucks as well, right? I mean, I really, really would love to have a few servers at home, like a rack and everything, but I haven't figured out the solution of heat and noise and all the other things. So, for now it sucks. Anyway, that's the nerdy part of me, I guess, talking. But so how can we do something flexible and something portable and open source and everything? Maybe there is something that can help us with this. And then you realize that, well, yay, there is this problem, there is the solution that can help me with this problem. And it was a friend of mine that showed me this tool set, or a framework called Apache Beam a few years ago. And then I was like, oh, fine, I can actually use this for two reasons. One, I can have a pet project where I can play around with data and convert it and understand this product a bit much better, this Apache framework. But then the other thing is actually I can actually solve a real problem. But still, you learn. This was just a learning experience for me. This was not a very kind of serious project that I did professionally. Not exactly this one. So just a few words about myself. My name is Rustam. I work and live in Oslo. I work for a company called Computas. I am also a Google developer expert for cloud, and I am also one of the Java champions. And it's a really, really amazing group of people. I mean, both GDEs, Google developer experts, and Java champions is a fantastic communities where you can share and thrive and do lots of cool stuff together as well. So back to this architecture and the idea of how can I build this thing, and well, the way I thought first doing that, and actually started doing that, was on a Raspberry Pi on my desk in my living room. So I had the tiny little Raspberry Pi running there for 3-4 months, collecting data and storing all that and doing all these kind of things. But the problem was that well, it's a Raspberry Pi. It's not very reliable. And at some point, after like 6-7 months into the whole thing crashed because, well, the memory card that it was running on just crashed because it's been writing and reading things all the time, and things happen. And it's a Raspberry Pi on an SD card, right? How reliable can that be on the long run? But the idea was the same. So you would have a cron job that would kind of wake up every so and so many minutes and dump the data. The way this API was working, so they were providing just a REST-ish kind of API, JSON files, basically. So I would wake this script up. I would download the data, the files, I set it up to do every 15 minutes. So 4 times an hour, it would dump all the information that it had, and it would do it 24/7. So I've been doing that for more or less now, I think, 2-ish years, around 2 years. So now I have a little bit of data, and that was actually quite fun. And the first thought was, okay, I put this batch data, I have this data in files, and I can put it into, I don't know, say things like Apache Spark, and then I can put it into some kind of data warehouse, and then I can visualize it somehow. And that's already a really, really good win. But then I also wanted to look at the possibilities of that was a possibility of doing this thing also with streams, because I thought maybe at some point they will start streaming their data, because, well, this is a cool thing, and this is what people might figure out doing. And I wanted to look also in the possibility of that. So then you would do some kind of streaming service with messages and everything, receiving all that, put it into, I don't know, things like Apache Storm, and then you can actually store it somewhere, again, some kind of data warehouse, something to do analytics on top of that and visualize it, right? So this was kind of the serverless Lambda architecture of this thing. And I didn't really want to have this kind of 2 different tracks, so one for batch files and one for streams. So what I realized was actually that this thing that I was talking about, that I mentioned already, Apache Beam, that would actually can do both without much changes to the code, as long as the data structure is the same and things are, and you've implemented it in a way that you want it, then it's you can actually do both, and you don't have to switch between different products even. So here comes the kind of the another Apache thing called Apache Beam. So what is this thing? That is an open source tool that's been open sourced by Google quite some time ago. So originally it was their thing they've been using, and then they created a open source project out of it and donated it to Apache Foundation. So it has one model. You create one model for your data, and then you can process with this model. You can do both batch processing, you can do stream processing, and generally it supports 3 Oh, good. I actually keep on reading questions in the chat. So there is a question from Baki about if I was running this thing in a cloud and stuff. Yes, I did. I will get back to that in a few minutes, so you'll see kind of the difference. So yeah, but the thing is here is that you can do batch processing and streaming streams as well. You can write your pipelines in Java. You could that was the first SDK. The other one that came a bit later was a Python SDK, and also now the latest edition of that is also you can write the whole thing also in Go. The cool thing is that it has this concept of runners. So you can decide where you want to run your model, and it can be different things. So it can be local runners. It's called, well, direct or local runner. that is running on your machine. This is kind of very nice for development and stuff like that. But then you also have a cloud runner. So you have one, for example, for Google Cloud called Google Cloud Data Flow. So it can run exactly the same thing on the cloud, but it can also do things with Apache Flink, with Spark, and all the other things. So you just basically plug different connectors, and it will just work. The cool thing about that is also which this model that gives you is that you create your model in Apache Beam, and the architecture of the framework lets you switch the components. So if you store your files on a file system just on your disk drive, or like SD card, or even a network drive or whatever, or if you put it on a Hadoop cluster, or if you put it on different storage providers like, I don't know, S3 from Amazon, or Google Storage, things like that, it would still work. You just need to switch one line, and as long as it's been written a plugin for that, it will just magically work. And the other thing, that you can also send messages to that thing through different messaging services. So you can do like PubSub on Google Cloud, and you can do Apache Kafka. You can do different things to kind of to get the messages ticking into this thing. The 2.0 version of the same architecture that I showed you earlier, as you might have guessed, was like this, right? So I have batch files, I have streaming, I kind of put it all into one model of Apache Beam pipeline model, and then I dump it into some kind of data warehouse, and I visualize it with, I don't know, Jupyter notebooks, or some kind of data visualization. Well, I don't know, say crazy thought probably, but like things like Sheets or Excel or whatever. But it's up to you really, about amount of data, how much work you need to do, and if it's like enterprise project or just your pet thing. So really up to you. And then the kind of the 3.0 version of that, after I had like the Raspberry Pi crashed, and I didn't want to set it up everything at home, and I just had like a development environment, and then I wanted to push it to somewhere, I decided to push it to the cloud. And kind of, well, one of the clouds that I ended up using was Google Cloud, but it would have been possible to do it on the other cloud providers as well. But here I had like a native environment for that. So Dataflow is basically a managed version of Apache Beam, which was really nice for me. So then I had a cron job. So if we replace all these parts of the architecture in different the cloud terms, that would be a cron job doing some kind of waking up and dumping data every 15 minutes. Then you put it onto a storage to store files and to kind of for those to be processed. And then you put it into Apache Beam model, you process it, you dump it to a database. And in my case, I decided using BigQuery just because I could quite a bit probably over-engineered, but it's over-engineering is a part of this kind of game, right? It's a part of the fun. I mean, who would have solved a bike problem with big data pipelines otherwise, right? So if it's worth doing, it's probably worth overdoing at some point, I guess. So a quick introduction to, so now you have the story, you have the kind of the problem I had, the way I kind of tried to solve it. Now I want to give you a short introduction of how to build pipelines. So in case of any of you have used actually Apache Beam, I would really appreciate to see if you just say hi in the chat and just like, mention that. But I usually do this talk, and there is not that many people that have seen this thing before. So I'm kind of, I'm going to do a bit more basic introduction, but you can obviously ask a bit more advanced questions in the chat, and I'll try to answer them as they come in. So pipelines. So what is actually a pipeline? So pipeline is basically think of it as a conveyor belt, right? You have you put like the way you put cars together or whatever, like any products together. You have lots of different parts in one end, and then you put it all into one moving thing. Well, obviously quite exaggerated example, but you put it all in a moving thing, and lots of things happening along the way, and on the other side you have a really nice, pretty shiny car at the end appearing. So this is basically a pipeline. So it's a directional acyclic graph of things happening to data, and then you have some other kind of data happening at the end. So directed, that means that it has one direction. It does not kind of jump back. It just goes one way. So, your car is moving just in one direction, from left to right or right to left or whatever, up and down, doesn't matter, just one direction. And the other thing is that it's acyclical. That means that there are no circles, because, well, if you do cycles, you will kind of go back in a way, or you kind of end up getting stuck. So it's not, there are no cycles, and it has a direction. So if you want to write a very, very simple pipeline, so I want to kind of show with the simplest pipeline possible kind of thing, and we'll do that in 4 different steps. So this is kind of my first pipeline kind of example code. Before I show you some code and some Java code, I want to show you the data. So this is the input data that I had to handle. So you'll see that there is a JSON object with stations. Each station has an ID, and each station has well, call it an object of availability. So it has a number of available bikes and number of available locks for that station, because it can be totally full. All the locks can be taken with the bike, and then when you come to this station to park your bike, you will not be able to do that. So you need the information about that as well. And this was the kind of the first data points that I had. I was just looking at this part, and to process this kind of data, I wanted to convert this JSON file into something I can relate to in relational database. I guess the drum roll there, but I wanted to have something that I can actually kind of process, and I wanted to have, as you can see on the previous slide, there is no date. So there is a timestamp at the bottom of the file that says updated at, and I wanted to have this timestamp for all the data points inside that file. For example, things like that, and some more, but this is like the first thing. So I wanted to convert it to something like this, right? So I want to have a table where I see the IDs, I have the availability of bikes, and I want to know when actually that data was happening and when that was collected. So this is the basic pipeline here. So we have input files. You dump all these things to a text files, and then I pick them up with Apache Beam. I read from files. I do that in parallel. I'll get back to that in a second. That's the kind of the whole idea of Apache Beam, or at least one of them. And then you do process the text lines. You do a pardo. I'll explain what pardo is. That's the part that is doing the parallel processing, and then I can massage the data in a way, so I can convert and transform the data the way I want it, and then I store it into the data warehouse. So I dump it. In the beginning, I was just dumping it to files, but then I switched a few lines of code and I started dumping it to a database. So and then I can visualize it and everything. So let's see some code. So this is the first one, is where you define the pipeline options. So before you create a pipeline itself, you need to define some options. And this is one of the this is an example of a possible option there, but the typically would be more. And you will see kind of, I'll share with you the code of this project. It's on GitHub, so you can actually see the whole thing in much more detail. But this is how you do it, right? You create a description, you create some kind of default values to that variable, and you create lots of variables like that that will help you to do things like, I don't know, say where the files are stored, so the path for the files, or the kind of the what do you call that, glob mask for the file. So I want all the text files, so star.txt, or all the files that start with 2020 underscore start.txt, or whatever, things like that. So all that goes as an option. And on top of that, then you just create a pipeline. That's no magic. It's just one-liner. So pipeline equals pipeline create. and then you provide the options that you've created. You've put into that options object, and then you start applying transformations. And the way you actually apply those transformations, if you remember this graph image, right? So you have something coming in on top, and there's a lot of things happening, and there is something else coming out at the end. And this is what you do with the data, right? You eat and process those files on top, and then there is a lot of things happening, and then you have this much better data structure and much better kind of thing coming out through this those transformations with the help of Beam. And the way you do that, you also chain them after each other. You say dot apply, and then you apply a transformation. Then they say dot apply, and then apply another one, and another one, and another one, and so on. And you can also even give them names, so you can actually see better which one it is and what it's doing. And I'll show you in a second why it might be useful. Pardues, I want to mention that really quick. This is the element-wise transformations. So parallel do, it stands for, and it basically is designed to process lots of things in like crazy parallel processing. So it can spin up lots of new threads, processes, machines. I don't know, depends on what you're using, but it will kind of parallelize in a crazy way, and it will just process all of it. And this is the kind of one of the powerful things with Apache Beam, because say I had 4 files an hour. So I had 4 different files, in 1 hour, 24 hours for almost 2 years. And if I wanted to process that all in one go, that will take me quite some time with just running on my quite powerful machine, like a laptop. But it will still take me a lot of time because it's a lot of files. But with this thing, even locally, it will go much faster, because it will just kind of split and conquer and just kind of decide which chunks of files which process will process, and just like, put it all in one place at the end as well for you. So that's a cool thing. An important thing when you write code for parallel do's is that to actually keep in mind that code has to be parallelizable, it has to be quick, and it has to be it has to be able to actually run in parallel. If there are lots of dependencies and things like that, and it's not really parallelizable, and you put lots of logic into that, it will be slow, it will be, well, probably crash, and things like that. So think about that, keep that in mind. And then the last step, basically the 4th step, is to run it. And the way I run it, like my example is just the Maven compile command, right? I just provide some options to it, and I tell it which class has the main is the main class, and then I provide some arguments to that class from command line. So, for example, things like input file path and things like that. And I also provide what kind of output I want. This is the things I decided to have as an argument. So you can have different ones. You don't really have to have them either, but it's just to show you how to do that. But the cool thing is, after that you wrote your code and you made it run locally, you can basically change a few lines in this Maven compile exec Java thing, and add some more options that's specific for the other runner that you want to run it on, and it will just run. You don't need to do any changes to the code. So if I just go back and forth, you'll see that, well, there is small changes here. So I have pdirect runner in the first case, I have pdataflow runner in the second one, and the other differences are that I provide a bit more of the paths, different paths to buckets and things where things are actually stored, and that's it. You don't really have to change any of your code. It just runs on this thing, and that's the beauty of it, right? So that was the pipeline version number 1. Was just a very simple pipeline, as I showed you earlier. This is a visualization from Dataflow. So this is the web view of my job that I run on the cloud, but this one is just to show you how fast did it actually run. And this is, I was processing around 7, 8, 9 months of worth of data. I don't remember exactly how much it was, but it was like almost a year, but not really a year worth of data. And you can see here, it just realized, oh, I have that many files. Okay, cool. I'll spin up what it says, 16, I think 16, 17 machines, process all that, and I'm done in 18 minutes. So the whole thing was done in 18 minutes with 16, 17 machines. The reason that it took actually 18 minutes, that it probably spent first 5 or so just initializing and trying to figure out things. I mean, things are a bit slow in the beginning, and then when it kind of figured out all the things and created a plan, it just goes crazy and just like bam, it's done. You'll see why I'm saying that, because remember, it took us 18 minutes. You'll see with much more data and much more stuff, it actually took us less, because first it scaled up much more, and the other one is that it actually, well, it's quite expensive in time consuming to initialize it, but when you initialize it, it's very easy to process a lot of data. Yes, I saw your question, Sebi, and I get this kind of question all the time. So what's the advantages of using Beam instead of just like Kafka Stream and stuff like that? Well, I'm not very well, the thing usually is, general answer is that usually you have these things to stream data, but then you still need to process it. You do need to do some kind of data wrangling, or kind of, you know, putting data the way you want. And that was the thing I liked with Beam. And my point of the whole project was to learn Beam, right? I haven't used Beam before. It was like 2 years back. I wanted to learn it, and I wanted to understand how it works. But my experience is that it usually is much better at like this parallelizing things and kind of figuring out, oh, I have to process that much data, and just figuring out all these things, how much data and how many machines and threads, and it has to do it in. And the other thing was also that you have this write once, run everywhere kind of model, which is also a very nice thing. But I mean, it's one of the products. There are several others, and you know, you can try the other things as well. So yeah. The first batch of data was not much. After processing all that, it was quite a lot of files. It was several hundred files, but after processing all that and putting in the way I wanted, I just had a bit more, well, 36 megs of data. That's nothing. This is not, it's not big data. It's not even close to big data. It's not even like a tiny little sibling of big data, right? It's just nothing. But still, I mean, it was still 1.1 million rows of data points. So in database, there was 1.1 million rows. So, you know, it was kind of reasonable. And that, as you can see, that's the data. That's the thing I had in 2018. And I started collecting that data probably 7, 8 months before that. So now I wanted to do another thing. I wanted to show you also another cool thing of Apache Beam, is that you can also do you can start several pipelines, and you can merge them together into one with a little bit of code, and then you can just kind of process the whole thing there. So now I wanted to add more data to my stuff. I had this availability data, but I had no idea where that station was. I don't know where station with ID 178 is. I don't know. I don't remember that. I don't want to remember that. So I found another API. So they had like 2 endpoints in their API, one of them to do the availability, and the other one was to provide a metadata about stations. And those metadata files would actually change quite often, because they would kind of change, add more stations, they would remove some stations, and they would do things like that. So I needed to dump that metadata every time I asked for availability to have this kind of updated view. It's not the most optimal way of doing that. It's not the prettiest way of doing that, but that was easiest way of doing that for my hobby project. But then I wanted to learn this thing of joining 2 pipelines, and that was actually quite cool. So I wanted to kind of even denormalize the data even more and put it into a data warehouse. So now I wanted to have an I wanted to have an ID. I wanted to have a bunch of data. I wanted to have a description where that station is, like an address or a textual description, things like that. I wanted to have a geographic coordinates, like GPS coordinates for that, and all the other data that I had, like availability and numbers and dates and things, and all the works. So now I was processing a bit more data. I was actually processing. So that was 600 megabytes worth of raw data. Still not crazy amounts of data. Still not like super mad big data project, but it's still something. It's much more. And now I had to do actually almost double the load in a way. So this was the pipeline version 2.0, where I would start two different pipelines, and at some point I would merge them with by ID. So I have ID on one side with availability, I have ID of the same station with metadata, and I kind of merge them and kind of explode the table even more with more denormalization and more data about that particular station at that particular point of time. That I needed to kind of create the trends and things like that, and to see how things are changing during, depending on like weekdays and dates and time of the year and things like that. And here you can actually see that what I was mentioning earlier. Here you can see the same thing was running for much more data, way more data. It's I think almost a year extra worth of data that was running in 14 minutes. So actually less time than the previous one. And also it did spin up, let me see, around 160 machines. So, well, now we have a totally different thing. And the cool thing was that actually when I was running this, I didn't really think much about money. So I didn't think about how much it would cost. And the thing that scared me quite a bit was that when I processed this data, I had 13 million rows of data. So instead of having 1.1 million, now I had 13 million. And it was in like processed data in the table, it was 1 gig worth of data. So now we're getting somewhere, right? It's a bit more data. It's a bit more kind of it's a bit more kind of volume. But then, the money thing, right? So then you realize that, I didn't really think about that. Like 120 machines, or 160 machines, or whatever that was like, that's a bit scary. And then I saw this on my billing. It didn't really, well, I did remove the amount of money in euros there for now, but then I saw this, like this first thing I saw with the red numbers, and it says, well, you've used actually 900% more money that you've used earlier. Congratulations, that's really nice. And I was like, well, that is not really nice. That's going to be expensive. And then so I jumped a bit in the chair until I actually realized what number is there behind the black square. Any guesses? Anyone who wants to guess? Like real quick? At least do it in your mind and just like think of a number that, 900% more than I used for last, I don't know, year or so, processing 600 megs worth of data, so hundreds and hundreds of files. Yeah, exactly. So 900% is enough to blow your mind. So yes, that was the total amount. Yeah, well, this was Ahmed, you're not that far away, a bit more than that. So 3.4 euros. So that's probably a price of what? I guess 2 coffees in Oslo. I mean, Oslo is expensive, but still, or half a beer, or I don't know, whatever you measure things and like, or convert the money amounts into. But yeah, 3.4 euros. So that is nothing. That's like that's nothing. And that was really cool because I actually didn't really cost me much. It just cost me like a few cents now and then. And then I did this crazy jump of 3.4 euros, and then it was down to nothing again. And that was much a bit more of a relief, because the thing is, you don't really see the billing thing until after some little bit of time. So you get really scared and nervous, and there is a cliffhanger for a little bit of time. Then you see that, and you're like, whew. And then you have this image of amazed monkey, right? Because we had a sad puppy earlier. Now we're a bit more into this amazed monkey kind of picture, and the mind. That was kind of my state of mind anyway. Yes, 1/10 of a burger in Oslo. That's pretty much, that sounds about accurate, I guess, Sebi. So yeah, the thing is, that was the architecture, right? So now I was actually being able to process all this data in batch files. But then I also wanted to look into the pipelines of a stream. So I wanted to also look into the streaming API of Apache Beam, which I did because, well, now I just had one of this part of the architecture, right? But I wanted to also have this going from batch to streaming. Unfortunately, I don't think I have time actually to talk too much about the streaming part. I do have slides and everything, but I think for now, we can just jump over that part, but we can always, you're more than welcome to ask and you know, share your thoughts and everything. The thing I really want to say is that with streams, things are different because now you have files. When you have files, you know when things are been done. You know that your data is kind of consistent. You have all the data for that time, whatever that would be, and you know, things like that. With streaming, it does not. So what happens with streams is that your data might arrive in like unknown delays. It might arrive at 8 o'clock. For data for 8 o'clock might arrive at 8. It might arrive at 9 or 8:40 or 30 or whatever, but it might arrive at 2 o'clock in the afternoon as well. So you know, that kind of sucks. You have to handle this. You have to put things into windows. You have to do like watermarks and triggers and accumulation and all those kind of different ways of doing that. I will not go into much detail into that, but then I want to use a few last minutes talking about some cool features that I've experienced in addition to things that I mentioned already. So some of them is that this windowing thing that I mentioned earlier is that you can with just a few lines of code, you can extract windows of data. And here, for example, you can do, for example, this one would get windows of data for last 5 minutes, and it would poll that every minute. That's kind of, if you had to write it yourself, there would be quite a lot of logic. Here you can just say, well, sliding window, duration 5 minutes, every 1 minute, and that's it. It will kind of create and return you that number of events or those events. The other thing is that challenge I had was actually to visualize the pipelines in a kind of automatic way, because when you do it on your local machine, it's impossible to visualize. You have to upload it to cloud or somewhere where they created that visualization thing, the thing that I've been showing you on the slides. But then I realized that there is a class that lets you dump data into this dot files where you can basically graphs you can visualize. And then I wrote a short blog post that you can see there. So take a picture of the screenshot, or I'll share the links as well on Twitter. But yeah, this is a cool thing, and this is kind of, it helps you a bit. It's not as pretty as you've seen on the clouds, but you know, it works. It does the job, and then you can massage it a bit more. The other cool thing is that you can switch. So I was processing files and putting them into files. Then I just switched with the click of a button or a few lines of code into processing data and put it into a database, a BigQuery in my case, but any kind of database would be really okay. Yeah, you can also do a lot of like replacing transformations and things like that. You just, instead of putting things to files that I kind of crossed over there, you can do the database, for example, right? Another thing also was that I plugged in another way of dumping into another database even in addition, and then I could visualize the stations and availability just out of the box, because that open source database that I used for that, it had this ability, so it was kind of cool. Yeah, so I guess I will, yeah, and then you can do things like this. So you write really crazy queries to all your denormalized data, and it will kind of show you all this statistics of things and trends. And then you can do trends and stuff that I showed you in the beginning of the talk, where you can actually know what availability is going to be predicted in 2-3 hours. And that's basically statistics that you're doing. Amazing monkey again. So, you're like, oh, wow, this is kind of cool. And that was my thing. It was a bit hard to get into, but then when I understood the model and everything, it was so much easier to get new cool features and things done. And yeah, well, one piece of warning is that your data probably at some point will change and your model will probably at some point fail. You'll need to still kind of maintain that. So just so that is said, it's not absolute magic. Just, if your data points change, if your data endpoints change, things need to be rewritten slightly. So it's all open source. This is the link. So take a picture of that link as well, or go to my GitHub. You'll see it there. You can actually run it. And if it doesn't run or you have any problems or questions, just ping me. This is me on Twitter. So that's R. Memedarov. That's me on Twitter. And you can also, shoot me an email or send me a message. My DMs are open. There are a few questions that I don't think I have. Are there anyone from the organizers here? Can you tell me if I have any time left, or should we do kind of questions somewhere else, maybe in the chat or something else? I'm not really sure what do we do with the questions, because I think I'm out of my time right now. But anyway, you can ask me, ping me on Twitter, send me a message, and oh yes, I have time. Perfect. Oh, fantastic. Okay, then I'll answer the questions that I've got so far. So if it increase coming data parallelism, does Beam help us to process data with more parallel threads? Yes, it does. Well, I mean, it will kind of figure out and do things automatically, at least try to do that, and then you can adjust that as well. But yes, it will do that, and it will kind of, you see, I mean, for me, it's just the number of files and amount of data that changed, but then I went from automatically parallelizing to 15 machines to 160 machines, so kind of 10 times same thing. And then the comment from Sebe, windowing is a cool feature to analyze behaviors. Netflix does it a lot using this technique. Yes, that's right. It is a very cool thing, and it's also very interesting to see, but it's probably mostly useful for stream. So for my batches, it was a bit more kind of, I had to do it a bit other different way, but yes, it is definitely, it's a very cool feature. Oh, thank you. You guys are fantastic. You folks are amazing. You actually post the links for me so while I'm talking. So fantastic to be here, and thank you very much. Again, if there is anything, ping me. I do speak and understand quite a bit of Turkish, so I mean, if you want, you can actually write things in Turkish as well. I hope whatever I answer you'll understand as well, because I'll probably answer in more closer to Azeri than Turkish, but you know, I'll still replace some words and everything to make it a bit more understandable for you guys. Thank you all for having me. It's been really great pleasure, and it's always fun to be in Istanbul. Thank you all.